Okay, today we will do some problems in tilted photograph. Okay, very small basic problems. That's sufficient. Okay, that's a sufficient. That's sufficient. So in a tilted photograph, a point A of an elevation of 500 meters above the datum has the image coordinates with respect to the what is happened what happened with respect to the Photogrammetry axis. Oh my God. Happened. Something is happening. Okay, Photogrammetry axis system as okay xa is equal to the minus 62.45 mm Photogrammetry axis system. Photogrammetry means we already know Photogrammetry marks. These are the Photogrammetry marks. This is a Photogrammetry axis. So okay, ya is plus 82.25 mm. So minus to plus, y is plus, so it will somewhere here. Okay, so see, if the tilt and swing respectively are 3 degrees and 220 degrees, determine the scale of photograph. That's it. So tilt is 3 degrees. What is swing, sir? Swing is this. You can observe it. Swing is this. Where it is? In a photograph, if you see the photograph, see. This is a swing. See? This is a swing. This is a swing. So I already explained why it is getting like this. See, this is a tilt. Tilt will get. So it is. How can you draw? So again goes to this. See, this is a tilt. This is a tilt. Tilt will go very small, 2 degrees or 3 degrees. Okay. So swing is we get new coordinate system because of Nadir point is different. Are understood? So this is a swing because we will get the coordinates for this axis. So this is x direction, this is y direction. This is another point. Okay, so if we get it, this is a tilt t. Okay, so we already write it. So this is theta, this is t. Okay, so see it, small, easy. Datum height is h is 2500 meters. Focal length is 152.4 mm. Okay, so now we can see swing is 220 degrees. We can get the theta is 180. Remove the 180, you will get 40 because we derive the formula. So now you can observe it. We derive the formula is this much only by this theta. Otherwise, see, we derive the formula by this. Otherwise, I will put red color. This is. If you see, total is 220. We remove 180, you will get this theta. So these formulas are based on this theta. Okay, totally swing, we derive the formulas based on this theta. Okay, no need to prove because it has some hectic process, steady process. Okay, that's it. See, this is theta is 40. Okay, so what is scale? Directly, what is scale? Scale is f secant t minus ya dash sin t divided by h minus ha. That is the scale in a tilted photograph. But in this, a ya is there again. Ya is there. Fiducial coordinate system. It's not a fiducial coordinate system. It's a different coordinate system. We have to get it first. Xa dash and ya dash. These are the fiducial coordinates. But we have to find out the coordinates with respect to the tilted axis, northern axis. Then only you can solve the scale, because every point has different scale. In the previous also every point has different scale based on the height, but in this some y also included in the scale. Why you get that y? We already discussed. I said where it is. See, this much, this value is come. So in the photograph you can observe it. So in the photograph you can observe it. This will come. This mn will come. Okay, this much coordinates is going like this. So these are all take care by system software. No need, but just understand it. Okay, so first you have to find out the coordinates with respect to the tilted axis. So what is xa? We don't not require. So we want only ya dash. What is ya dash? Ya dash is xa sin theta plus ya cos theta plus f tan t. That is the y coordinate. If we get that values, xa is what? 62. This is minus 62.45 sin 40. Ya is what? 82.25 cos 40 plus focal length is what? 152. Tan 3 degrees. We get it like, you get it plus 30.86 mm. You also find out the coordinates of xa also, but no need. So then you can find out s. S is f secant t minus ya dash sin t divided by h. H is what? H is 2500. H, small h is height. Height 500 meters. Height 500 meters. Yes. So substitute it. You will get. So 1 by 32, 13,246. That is the scale. That's it. That's it. That you can find out the scale in a tilted photograph. Okay, that's the one problem. Second problem we will see somewhat more problem, somewhat lengthy problem. So now we can see, determine the length of A, B on ground. So we already solved one problem in a vertical photograph. We calculated the length of AB. 2 points. If you find out the 2 points, we have to find out the coordinates in the ground. Coordinates in the ground. Later we will use direct formula, root of xa minus xb whole square plus ya minus yb whole square. That's it. Now same thing here also. So find on the ground. So see, flying height h is 2500 meters. So elevation of A is 500 meters. Elevation of B is 800 meters. So tilt 3 degrees. Swing again, swing 220 degrees. Focal length f is 152.4 m. So coordinates, A coordinates, small a coordinates on the fiducial system mark. Fiducial coordinates A, xa is minus 62.45, ya is plus 82.25, that is the point. B is plus Same I will write. XB is 78.25, YB is minus 41.45. So this is the point based on the potential system mark. So okay, we have to find out the tilted axis coordinates. Okay, so see, so tilted axis coordinates is what? For a what is for a point, tilted coordinates is xa dash, ya dash. So how can you get it? Xa dash is what? Xa cos theta minus yb sin theta. So ya dash is xa sin theta plus yb cos theta plus f tan t. We already shown it. So use it for a coordinates. For a coordinates, xa is, you will get it minus 107.1, ya dash you will get it plus 30.86 mm. That's it. Same you can use it b, xb dash you will get it plus 86.39 mm, yb dash you will get it 26.7 mm. These are the tilted axis coordinates. So once you got on the photo coordinates, you have to find out the coordinates on the ground. That's it. So what is the coordinates in the ground? xa dash, what is that? Same xa dash multiply with reverse scale, opposite to scale. So what is scale? H minus h is f secant theta minus y dash sin theta. That is the scale. So opposite scale 1 by s. You will get the coordinates on the ground. So if you want to get the coordinates in the ground, you have to just multiply with opposite to the scale. Otherwise, if you know the ground coordinates, you want to find out the coordinates in the photograph, multiply with the scale. So that is the meaning of the scale, increase or decrease. That is the scale. So what is the coordinates? So you will get it minus 1334.0 meters. You will get it. So you can find out the scale also individually. If you know the scale, you can just multiply with. Otherwise, directly use the formula. No need. Okay. So, ya dash capital, same ya dash 1 by scale. You will get it 408.24 meters. So xb dash, you will get same thing. So xb dash 1 by scale, you will get it 971.2 meters. Yb dash, you will get it 300.56 meters. These are the coordinates on the ground. So once you got the coordinates on the ground, so what is area? Area is what? Root of xb minus c capital. So okay, small capital X. xb xa whole square, yb ya whole square. That's it. That's it. So use it, you will get 2307.6 meters. That is the length of that line in a tilted photograph. Not in a photograph, in reality, on the ground. So that's it. That's it. Those are the small problems. Okay. So finally, tilt displacement. Tilt distortion also. Tilt distortion also. You will see the problem. Very small problem, basic. The radial distance from isocenter to an image point above the axis of tilt was found to be 95 mm. The clockwise angle between the principal line and the radial line from the isocenter to the image point is 50 meters, 50 degrees. Determine the tilt displacement. Tilt displacement of image point. Okay, so F is 152.4 and tilt is 3 degrees. I again said previously problem, see what is the tilt, what is the tilt, tilt distortion, see this is a tilt, see tilt. So if you take a picture by vertical and if you take a picture on tilt photograph, the point position is changing. How much changing? Radially from isocenter, not an optical axis, from isocenter. Because if you take the isocenter only, the images you can observe, you can visualize it is shifting to rectangular to the parabola, so trapezoidal. See, these are the two same pictures. Are understood? So how much this R is changing this radially, not an x-axis, not an y-axis. So this point is, changing this. So if this take this corner, this changing. So this corner change this. How much is changing? That is the chance. Okay. So that is the only tilt distortion. If you want to see the proof, see hectic proof. No one needed this much of proof. No one asked. So that's why I gave it this equation. Okay. So we will use it. We will use it. Straightforward. dt is ri whole square sin t cos square delta divided by f minus ri sin t cos omega. So proof is not required, that's why I left it. Otherwise we have to take care of why it is, how it is, you will get it. But no need, because if you see the syllabus, they just mention one line tilt distortion. There no one asks tilt photograph, tilt displacement, tilt coordinates. No one asks. If you know that value, that meaning, you can idea what is the tilt. So we extend this to at least one class. For one class this is sufficient. No need to discuss this proof. Okay. So see, this is the radial distance of that point. So what he gave, this is a 95 mm. 95 mm sin t 3 degrees. This cos 50 he gave it is there. So what is this? This is a clockwise angle between the principal line and the radial line from the isocenter to the image point. So in the previous diagram you can see, observe it, alpha, delta, alpha, gamma they given. Then later they are clubbed together, form as some delta. So no need of proof. Okay. So divide by, this is 152.4. So Ri is again 5 sin 3 degrees and cos 50. Okay, that's it. So if you get it, it's 1.31 mm. So just observe it. Just observe a value 1.3 mm. So you can't get 10 mm, 20 mm or 10 meters, 20 meters, because in the photograph, the position of the point, from the isocenter, how much is changing when we took the photograph is vertical, when we took the photograph from tilt photograph. Just a small change will happen, because tilt angle is 3 degrees, not 10 degrees, 20 degrees. Very small tilt angle is 3 degrees. That's why the position is changing to 1 mm. 1 mm is changing. In reality, just changing 1 mm. That's it. That is the idea. Okay. So that's it. These are the small idea about the tilted photograph. That's sufficient. So no need to discuss. No need to discuss again and again for this tilted photograph, because those are this very small understanding. So everything take care of the softwares. No need of feeling. Okay. So that's about the tilted photograph. We again comes to the stereo photography. So what we discussed the stereo photography. Remember what we discussed the stereo photography, where it is okay. Where we discuss stereo vision. We discussed extensively on stereo vision. So when we close one eye observe one images in observe 2 points one behind other, and we again open that eye and close another eye, you can see it. If you observe it, the point behind that point behind that objective is shifting from rightwards to left side, is shifting na? But in reality there is no shift. But if you see one angle and if you see the another angle, you may observe or you may feel that the position of the object is shifting from one location to another location. That's why you can't exactly visualize the depth between those 2 points. You can't get the depth between those 2 points. That is a compulsory. You have to fix that parallax. That is the parallax error. You have to fix that parallax error. Then only you can idea getting the exactly the depth. If you know the depth between those 2 points, then only you can draw three-dimensional view. Three-dimensional view of that points, every points. Understood? The digital image is what is exactly, not only exactly related to the surveying. So this is almost beyond the surveying. Surveying we just required position of the points, that's it. But in this is somewhat advanced. In advanced they develop the images in three-dimensional. How much depth, how much the elevation difference between any 2 points, everything we can get from the photographs. We can directly get into the digital images and we can exactly simulation, get in the simulations, you can directly see the three-dimensional view of the total plan. That is the idea of this stereo vision. So for that stereo vision you need at least two projections from one side to another position at a time, then you can assume. So for that we can't do at a time. So for flight we have to take care of at least two sides, from one side, right side and left side. We have to take care of the project, do the projection on that point. Based on that we can eliminate the parallax error. Sir, how can you eliminate the parallax error? We will see. Now we will see. So if you just see, this is like we take a photograph from this angle, we take a photograph from this angle, we can both club it together. That is, we can eliminate the parallax error. Okay, so how can we see? Today we will see. Today you can see. So now we can observe it. Some point is there. Some point is there, A and B is there. Look like so, A, B. So this is an, you can call it as A, B. See, you will see, observe it. This is the optical center. This is an optical center. We have take care of, we can do one photograph. This is an exactly the optical axis, can taken as optical axis. So for this optical axis you have to, that's it. Okay, like this. See one thing. So A image is like somewhere here. This is an exact. B image is somewhere here. You can take it. Okay, on plane, on photograph. So you can observe it. This is an XA. Okay, this is an XA. This is an XB. Okay, so you can idea. So this is YB. This is YA. So no need at all. So left it. So again, if you take in, we will observe the same points. We will observe the same points on next photograph. Next photograph now. So next photograph. So is base clearance. You can call it a base clearance or aeroplane base value. How much distance we take a photograph based on flight planning. We already discussed yesterday. How many photographs are required to cover the total area. Based on that, you can easily capture how much amount, how much distance between any two photographs. So again you can observe it. Again you can observe it. You will get the photograph. Photographic coordinates. That's it now. That's it. You can observe it. You can observe it. Again if you see, XA will come like this, A coordinate, and B coordinate is like. So if you see, same. So now this coordinate system I call it as this X, this Y, X dash and Y dash. This is X and this is Y dash. See Y. Just feel it. Sir, this is, you can call it as, this is K dash, this is K. If you observe it, the K also, this K dash also, this point also comes to this maybe N. Sir, maybe some chances are there, these 2 points are not covered by the 2 photographs. Compulsory these are covered. So because, see, 50% image is covered. At least 50% image is covered. Na? Every photograph is 50% covered. So this right part, compulsory covered in this right part. That is a 50%. At least we maintain 60%. At least we maintain a 60%. So compulsory this potential marks up to this potential marks and beyond also, beyond 10% also comes to this in this first photo. At least 60% we maintain. Na? So that's why compulsory chance is there. Okay. So this K dash also it comes somewhere here. So this K also comes somewhere here. Somewhere not in it, somewhere here. Because at least 60% we maintain overlapping distance. Okay, observe it. So now you can observe it. This is XA dash. This is XB dash. Okay, XA dash, XB dash. So now you can observe it. Now you can took it. For first photograph, the A point is here. Here. For the second photograph, A point is here. So first photograph is right side. For second photograph, the point is placed on right left side of that based on the potential coordinate system. These are the potential coordinates. Okay. Based on the potential coordinates, the second photograph in the second same point located on the left side. For the first photograph, it's right side. So that means see, same photo, same point, same projection. So now you can shift, not a shift, just replica. The same point of second photograph, XA dash, I will replica on the first photograph. It may comes at this point, and then at this point, XA dash. So B point also very small, somewhere here. Just locate it. This is XB dash, just small. What is that, sir? Why you did that? So that meaning is, just observe it. When you see the same point on two different locations, the shift of that point from one position to the another position, how much shift? That is the parallax error. Na? That is the parallax. If you took the same point from one location to the another location, how much shift is taken? That is the parallax error. So how much shift is there? The same point, first it is located here. The second is located here. So exactly I replica in this here. So total shift is what? Total shift length. First is XA distance from the coordinate axis. Second is minus XA dash. So total how much is shifting? This is the shifting. That's it. The same point in the coordinate system, how much distance is shifting in the photograph? So this much, this much is shifting. See, this much is shifting, total. That much distance traveled, not a travel. That much distance is shifted. If you took two photographs, so that is called a parallax of that point. So same point B also. If you took care, so if you take care, so how much shifting happen? This much. So this is a parallax of B. This is a parallax of A. That much distance is shifted right side to left side. Understood? So same thing you can write down. xb plus xb dash is a pb. That is a parallax in the b point. Parallax in the point. Sir, why, how can we use it? So we will use it. See, we can use it based on the parallax error. We can find out the height of the points, a height and b height, a height and b height. So first you got this idea. What is the parallax? Shifting of that point from one location to the other location. That is the parallax in our vision. In our vision, that is the much parallax, na? When you observe from one right side, one, so previously if you see, when you observe, it is, when you observe from one location to another location, how it is shifting. So for this side we, you can observe somewhere the point is behind point, somewhere you can see. For second point you observe the point is shifting. Just observe it. Any two points in your room, one besides the another, you can close one eye and see that back point. You can feel that is there some point. Now you can open that eye, close the another eye. You can feel that and the lighter point is shifting. So how much it is shifting? That is the point. How much it is shifting from one location to the other location when we took the photograph. That is the parallax. Okay. So that is an idea. That is an idea. So this is a parallax in the A. This is a parallax in the B when our flight planning. Based on our flight planning. So okay, that's it. That's it. Now you can see based on that, you can find out the depth of any point. So how can you find out the depth of any point? So now you can see same picture. So we will took only one point now. One point. This is the optical axis. Okay. This is the projection point. This is the projection point, focal point. So we'll took two photographs. This is A, you can call it as. So if you took the photograph, okay, somewhere this point is there. So okay, this is an X, this is an Y, XA, YA. So same thing, you will get it. Same point is there, you can use that point. So that projection. So see, this is XA dash, that is YA dash. Okay, this is small XA YA. Same one point. That one point is at some height. So you can write in some based on the geometry, it's some height, h height is there. Okay, h height. So this is total height h, flying height. This is an elevation, small h, you can take it elevation. So now you can see the ground coordinates is exactly, this is capital small h, that is the ground coordinates. That is ground coordinates. This is a small, same point but two pictures. That is the ground coordinates. That is the ground coordinates. Just observe it. Now we can observe it. We already discussed this to taken. This is a focal length. This is a focal length. So what is the ground coordinates? How can you write ground coordinates of XA? How can you write it? Sir, small a. So small a multiply with inverse of the scale. That is ideal case. That's it. That's it. One thing. No problem at all. So YA, same YA, you can write it, but no need of Y. Okay, there it. Now we can observe it. For second case, see, for second case you can see, observe it. So this xa dash, can I write, this is a flying light, na? This is b, flying distance, for one space distance, na? So one photograph flying distance, that is, you can call it as like, right, air base, you can call it as an air base. Okay, this is air base. So for one photograph, how much the effective area call. So when where took two photographs, in between the two photographs the distance in the ground, on the ground, is called air base. Are understood? That is air base. So now you can see this xa, you can write is b minus of xa. Can you write it? B minus of xa. Can you write it? So now you can see, observe it. Now you can observe it. Same distance. Same, observe it. Same, observe it. B minus of xa. Okay, B minus of xa. This value is equal to the f by h minus h. Same thing. This is now minus xa. That's it. So minus xa means what? This minus xa dash. So we just write it. So if you directly write it, so what is capital X dash is what? Small xa dash. So f by h minus h. That's it, na? Same. We will write same it. But now we will remove b xa dash into b minus xa. That's it, na? That's it. I did only one change. Only one change. So now you can write out. Now you can write out what you can write it. Now you can write it. So xa, what you can write it? Xa you can write it b plus. So what you can write it? B plus. Sorry, one thing you missed it. Where you missed? This is an opposite. This is a maximize. This is a maximal ground coordinates, na? Ground coordinates you have to directly multiply with. For you getting the ground coordinates, you have to multiply with opposite. So that's it. I just missed it. Okay, I just missed it. Just it. H minus h by f. Okay, that's it. Same thing. I missed it. H minus h by f. Here also getting the ground coordinates. Okay, now you can observe it. B plus xa dash h minus h by f. That's it, huh? That's it. So you will get the C. You will get like, now you can see both are this represent same coordinate, same value. So now you can see, compare with, not a compare, both are equal. xa h minus f is equal to b plus xa dash h minus f by f. Understood? So now you can write down. Now you can write down. So what you have to write down? So what you can, h minus h by f xa minus xa dash is equal to the b. That's it, now. That's it. So now what is xa minus xa dash? That is the parallax error we discussed. That is the parallax error. This is, na, we write in a absolute coordinates, there are no uses of minus. So plus or minus they don't take care. That's why they xa minus xa dash. So this is minus of this minus coordinates. So that's why you will get it minus. That's why they used it plus. Okay. So the shifting of the same point on two different photographs, that is called parallax error. Now you can observe it. That is the same value here. in where otherwise if you use here you will use plus xa, you will get plus. Okay, so no, don't take it, right? So that means what, this is a parallax error of that point pa. Are understood? So h minus f pa is b. Okay, so now you can write down h minus h is equal to the bf divided by pa. So what is h? H minus of bf by pa. That's it. This is a point na? You can write down. That's it. The point height ha, the point height h, this h, otherwise this h you can find out based on the parallax error. Parallax, but this is the real, sir. We already find out the same height based on the scale in from previous problems. So what is the difference between? So that height is you can't use exactly, but in this height, if you find out the height by this parallax method, you will get exact answer. There is no change at all. So there is no problem. If this is exact, previous compared with this. Previously we also discussed in to get the height of that building or height of the elevation of the points. Okay, so this is the best way. So same thing, you can get the height of the another point also, any point pb based on the parallax of the point. Okay, xa xb. Okay, so you can find out the height means what, depth. Height means what, the depth. You can get the three-dimensional view. Are understood? You will get the three-dimensional view clearly. Three-dimensional view. So capital X and capital Y and also Z, 3 dimensions you will get it, and you will get three-dimensional view by the photographs. By the photographs you will get the three-dimensional view, and also you will get the same, sir, you will get the height in a parallax error. So you also know the coordinates in x and y also in parallax error. So how can you get, what is x, what is xa, what is xa, capital xa, and the ground, what is xa, small xa, h minus small h by f. That is the coordinate. So you will use this h height, you will use that, what you will get, h minus pf by pa divided by f. H will cancel, xa pf divided by pa f cancel. So what is it, xa is what, small xa b divided by pa. That's it. Coordinates same, y coordinates also same, y coordinates also y of a b divided by pa. X coordinates, y coordinates, and z coordinate, third coordinate. You will got it now? So otherwise same, x b point, another point b, parallax of point b, y point yb b divided by parallax of the point. 2 points coordinates on the ground, and the depth also, this is the depth based on the parallax error. You can analytical, you can use this analyticals, this is the formulas into a software or coding. Based on that, digital images will come. Depth, width, so coordinates x and y and z also, by reducing the parallax errors. Based on the parallax error, so you will get the exactly the three-dimensional view. Are understood? You will get the three-dimensional view. So and also you can find out the difference between any 2 points also. Difference between any 2 points heights. Difference of elevations in 2 points. What is difference? Any difference is hb minus ha. So same, you don't feel h minus bf by pa cpb 1, h minus bf by pa. That is na 2 points elevation. So just it in this, there is no p points, you will get it pf by pa, pf by pb. You can directly bf 1 by PA, 1 by PB, P of, so difference of parallax error in B point and A point. So PA, B minus PA will come, PA and PP will come. That's it. That is also differential of elevation of B and A. You will get it like this. Like this, you will get any more formulas also. So not only one, you can get so many formulas you can develop. You can develop here like this. Okay, you can develop like this. You can develop like this. Okay, so in terms of another also in terms of H, capital B, you can write it. You can derive any formula. So in the parameters of anything. So we already know so many formulas are there. You can develop anything. Okay. So no need of so many formulas. That's enough. Got it? That's the thing. That's the thing only I require. I will do one problem. So that's it. Today the end of the stereo photography. This is called stereo photography based on the parallax error. You will get the third dimension coordinate. Based on that parallax error, you can develop a three-dimensional view. Okay, parallax error of any point. So every point has different parallax error. Are observing? Every point has a different parallax error. Each point has changes to parallax error. So how to find out the parallax error of the points? That is another topic. So I don't want to discuss to how to get the parallax error of every point, how to minimize, how to get a uniform parallax error of every point. That is another topic. So if you go through those topics, I said it's a photogrammetry is a textbook. Textbook is a separate course. Now see if you just observe it. Nowadays drones are everyone in every YouTube star using the drone videos, drone shots. So based on the drones, also we can use survey. So nowadays what they did, previously they used helicopters, aeroplanes. Now we just by the drone, they capture the photographs. Based on the photographs, you can get the topography of the total area based on the photographs. Na? So same thing if you search in the YouTube, photogrammetry something, everything explained with respect to the drones only, not in this. This is a old, not a old, it's previous. This is used for the army to survey of a large area. By this drone, you can get the very similar small area. Based on the same technique, nowadays using the drones, they capture photographs. By the photographs, they develop a topography of that area or everything. Okay, drones, photos taken, everything similar type. So I will do one problem and close this topic. Tomorrow, next class, we will discuss another theoretical topic. There is no problems, nothing. Okay. So see what he has. The image of two ground points A and B, and once again said to capture the parallax error of that point is another topic. So I don't want to discuss that topics also because almost it's a fourth class, but one class is skipping, one class is wasted at. Okay, one class wasted, and again one theoretical topic is required, and again terrestrial topography, that is one class. So they assigned for 6 classes for this topic. Okay, okay. So the image of the two ground points A and B appear on the two photographs and have the following photo coordinates with respect to the flight axis. So XA 51.23, YA 48.33, XB 91.48 mm, YB 51.63 mm. If the parallax error in points A and B are 91.3 mm and 94.26 mm respectively. Okay, respectively. Determine the ground coordinates and elevations, three-dimensional. See, three-dimensional elevations of points A and B, and again horizontal length of AB also. Airbase is 425 meters, flying height 1350 meters. That's it. They gave 2 point coordinates A and B on the photographs. Okay, so two points are appeared on the photograph A and B. Okay, they have parallax errors also, they gave it. So now we have to find out the coordinates of that point. So x, y and elevation, three-dimensional coordinates, and also they ask distance between those 2 points. That is easy. So now we can see. So what is the parallax error in A? 91.35 mm. So to find out the parallax error of that point is another topic. They have some different bar method, different methods are there. No need to discuss. In some textbooks, they discuss something later. They incorporated that is also in the problem, but no need. Okay. PB is 94.26 mm. So now you can see elevation of that point HA. You can find out what is HABF by PA. That's it. Simple. That's a simple. What is height? 1500. B is air base 425. F is focal length. I gave it or not? Focal length. Focal length is 152 point. Where I gave it or not? So otherwise I will give it. Focal length 152.4 meters. 152.4 mm. This is the focal length. Focal length is in mm, not meters. Okay. So, okay. 152.4 divided by parallax error is 95. So you will get it. What is that value? That value is 820.97 meters. That is the elevation of height point. Elevation of point A. Elevation. Say you will get elevation of point B. Same H, B, F by parallax error B. So use it, you will get it. 842.86 meters. That is the elevation of point B. Okay, that is the point of elevation. So they ask another coordinates also. XA point, ground coordinates, capital. Small a, H minus H by F, but no is. So in this we find out the accurate based on the parallax error. So based on the parallax error, what we derived? That is exactly XA. So XA P divided by PA. That's it. Just now we derived it. So what is XA? XA is 51.23. 51.23. B is air base is what? 425 meters divided by parallax error is 91.35. So what you get? 238.34 meters. That is XA. So, and also you can find out XB also. Parallax error of B. You will get 412.47 meters. YA also you will get same thing. You will get YA 224.85. YB you will get minus 232.79 meters. These are the YA, YB. So now what is the distance between AB? It is a simple. xb minus xa whole square, yb minus ya whole square. So what is the distance? Distance is 489.44 meters. That's it. So if you incorporate these formulas into the coding, you will get the digital image is exactly accurate. Three-dimensional view, x coordinate, y coordinate on the ground, and also the same elevation also. You will get three-dimensional view visualization. Are understood? So that's sufficient. One problem is sufficient, I think. Okay. So that's the stereo photography. That's the end of the stereo photography. So why we require stereo photography? So what is the use? What is the meaning of stereo photography? What is the parallax error? How to eliminate it? How to capture the parallax error? So everything we discussed it. I think that's sufficient. I think so. Next class we will discuss another topics. Okay.